Today we have got the problem of shortest path or route. So in the previous class, in the introductory class of network analysis, we have learned what are the what is a network, what is the arc, what is a node, what are these numbers represent, what is the weights. Okay, so in this class we are going to solve a particular problem on how to find the shortest path or route. Say I have taken a problem. So this is a typical network given over here. These are the nodes, you can see A, G, E, B, C, D, H, F. We have got a 1, 2, 3, 4, 5, 6, 7, 8. All total 8 nodes, you can say. So let us say we have to reach D. Say this is the destination, and A, say this is the source. Now before directly going into the problem, I'll just say you a few words like this is the link, these are the links. What does this represents basically? The cost of a link, these are the costs, say these are the costs 2, 6, 2, 1, 3, 2, 7, or weights what we have earlier learned in the previous class. And say for this particular network, these are the costs. This cost of the link may be a function of, you can say, distance, or it can be bandwidth. As I already told you that this particular network analysis is a interdisciplinary subject, you can say. Computer science guys are also using it to solve their particular problems. So we may be dealing with distance or bandwidth or average traffic, communication cost, or delay, and etc. So basically we have to reach, our motto is to reach from A to D and in a shortest path. In mental calculation you can have, you can also find by guessing the routes, just by adding the weightages of the routes, and you can find the shortest path. Look over here, you can have a guess, wild guess. Let us see A, B, C, D. How much it gives? 2 plus 7, 9 plus 3. It is 12. Okay. Now you can have this route A, G, H, D. 6 plus 4, 10 plus 2, 12. Okay. So this route and this route, the weightage remains same. Now let us see, we go this route. A to B, then E, then F, then C, then D. So it gives 2 plus 2, and E to F is given over here. Sorry, I forgot to write. It is 2. So A to B, then E, then F, then C, then D. It gives 2 plus 2, 4, plus 2, 6, plus 3, 9, plus 3 gives you 12. So this also gives you 12. Okay. And now say we go this way. A to G, then E, then F, then C, then D. This gives 6 plus 1, 7, 9, 12. This is 15. This is a promised. So by guessing the different routes, or by probable calculation of different routes, you can also find out the distance, shortest distance between A to D. But if you want to do in a what do you say, a particular prescribed manner, you can use Dijkstra's algorithm, which will, I think it will take much lesser time than guessing one. Okay, look, this is a short, you can say this is a short network. But if you are having a large network where the number of vertices can be around 10 to 15 or more than that, then guessing the different routes will be a time taking or time consuming or confusing one. So we are going to learn today Dijkstra's algorithm to find the shortest possible path or route for this particular network. So let us start with this A. Say this is the source. I can write this is the source. So obviously its cost will be 0. Okay. Now we have got 2 and 6 over here. I can write it for you. This is 2 and this is 6. Okay. Now let me write it over here. This is 2 and this is 6. Look, the A I have taken as source. The cost will be 0 from here. Now we have to move from A, and calculating the different weights, the minimum weights, we have to go to destination D. Okay, so Dijkstra's algorithm first step is to assign the different nodes as infinity. It is the first step as said in Dijkstra's algorithm. Okay, so I am assigning all the nodes as infinity. They are assigned. This is the infinity. Okay, the first step is to assign all the nodes as infinity except the source one, as because we are starting from the source point and we don't know how much we have to travel to reach A or C or E or F or G or H or D. So first step is to assign infinite distance. The next step, we have to find the shortest possible path from the starting from the source. Now let us have a look from A. If you start, we have got two routes. One is 2, the weightage is 2, say this is the distance or cost or whatever it is. We have to find the list of the paths, weightage of the paths. So starting from A, if you reach B, then 0 plus 2 will give you 2. Okay, so we can write over here, the next step we can write over here as it is 0 plus 2, that is 2 comma A, as because we have moved from A to B. So 2 comma A, the next step is done. Now the second route is A to G, which gives you 0 plus 6, that is 6. So we are going to write here only, that is 6 comma A. Okay, now you can see B gives 2, value 2, and G gives value 6. So obviously we can say we can make this route as a fixed route, as because it is the lowest. So I am assigning this route as a fixed route. Okay, next from B, two routes are emerging out. This value is they have given over here as 2. Okay, so from B, if you go to C, 7 plus 2 gives you 9. So I can write it over here as 9 comma V, as we are coming from B, not from F or somewhere else. So we are writing 9 comma B. Okay, now come to this point E. Coming from B, if you come from B to E, 2 is already here and 2 is here, so we have to add this 2 up. So we are getting 2 plus 2, 4. Okay, so we can write over here as 2 plus 2, 4 comma B. Or you can reach E from G also. Say for instance, if you take this path, say after coming from A to G, then we are moving from G to A, we will have to incur cost or distance or whatever you say. 6 plus this is a 1, is the one value given over here. So 6 plus 1 will give you 7, and you have to write 7 comma G, as you are coming from G to E. So 7 comma G. So you can easily confirm that. You need not to write that, or whatever, you can write it as you wish, and then you have to select the list of the 2. So I am not going for the G path, that is 7 comma G. I am directly writing 4 comma B. Okay, so you can easily see that this is the shortest path, so you can mark it as a permanent one. Let us mark it as a permanent one. That is A to B, then we are moving B to E as 4 comma B. Now the next The next path gives you E to F. This is obvious path. Okay, E to F. 4 plus 2 gives you 6. Okay, so 6, you have to write 6. Comma E, as you are moving from E to F. Now you can have a different option also. You can check it. Say you are moving from B to C, then, or you can say C to F. Then it will have a cost of 9 plus this one is given over as 3 over here. So 9 plus 3, 12, which is much greater than 6. Now the next possible route to reach F is, this is the 6, this is the, say this is the 7, this is the 9, which is also greater than 6 comma E. Okay. Now the next route, 6 plus 4, 10. Okay, and you can go there, 12. This is also greater than 6 comma E. So I am not going to write all the values, all the possible values. I am just only writing the permanent ones. If you wish, you can write the alternatives also side by side. So I am marking this path as the permanent one, this path. Now the next one, say you have to move from F to H. Okay, so F to H gives you, look, this is already 6, we have got 6 comma E. So F to H, 6 plus 2, that is 8 comma, where from you are moving F, so you can write F over here. Okay, no problem, I think. Now say you want to go from F to C. Say for instance this gives 6 plus 3, 9. Okay, so you can write it over here as 9 comma, you are coming from F, 9 comma F. Now we have got two routes. Here it is 9 comma F, here it is 8 comma F. It is obvious that it is the least one, so you have to select this one, this route. So I am going to permanent this route. Okay, the next route you can see, here is 8, here is 2. So 8 plus 2 gives you, I can write it over here, it gives you 8 plus 2, that is 10 comma, you are coming from H, so write it H over here. Or say you are coming from C and you have value 9 comma F, so you are coming from C and having 9 comma F. 9 plus 3 will give you what? 12 comma, you are coming from C, 12 comma, I am going to write it for you, 12 comma C, if you are coming from this direction. So you can easily say that this route is the least one, as because the value is 10 over here. So you will prefer this one. So I am going to mark it as permanent. So now the destination is reached from source A. Now you can have the network. You can just simply draw the network as here. Say this is A, this is B, this is E, this is the F, this is the H, and this is the D. So this will be the shortest path. You can name the nodes A, B, E, then you have got F, and you have got H over here, and you have got D over here. Just write the names over here. This is the 0, no need to write. For B you have got how much value? 2 comma A, 2 comma A. For E you have got 4 comma B. For F you have got 6 comma E. For H you have got 8 comma F. For D you have got 10 comma h. Okay, so you can say this is the shortest possible path to reach from source A to destination D. So I think and the value you can write it, you can tell it from here, 10 only. Okay, no need to write separately. This is a 10 total, whatever you can say, it is the maybe the distance or cost, whatever you say, total value is the 10 number. So this is all about finding the shortest path or route in this particular network analysis problem, okay, using Dijkstra's algorithm. Thank you.